Hello and welcome dear viewers to the another topic on dissolution testing. In this topic, mainly the sinkers will be discussed in detail. When sinkers are required to be used, what are the different types of sinkers, why sinkers are required, what is the requirement, how these sinkers are selected, and what are the pharmaceutical requirements for sinkers or related to sinkers, and the other requirements for the formulation based on each specific formulation that will be discussed. Also, in the last part of this topic, we will discuss the best practices whenever we are using the sinkers. So let's start with the video. See, dissolution is a key performance parameter for the formulations, and whenever the formulation is solid oral formulation mainly, that time lot of regulatory requirements are there, and the queries are given by the regulatory authorities mainly on the dissolution, because dissolution test is a performance test and the dissolution is impacting the bioavailability and the bioequivalence. That's why the dissolution topic is very important. In this video we will discuss the use of sinkers. So what is sinker? Sinkers are the material or accessories for dissolution testing which are required or which are used to sink the formulation at the bottom of the dissolution vessel. So sinkers are used to hold or retain a solid dosage form at the bottom of the dissolution jar or dissolution vessel for testing when the dosage form or formulation is floating or it moves into the dissolution bowl. The sinkers are selected based on the formulation or dosage form. See, generally the apparatus 2, that is paddle apparatus, USP apparatus 2, paddle apparatus is the common apparatus for many of the formulations. So the paddle apparatus, in the paddle apparatus 2, the dosage form is allowed to sink at the bottom of the vessel before the paddle starts its rotation. And if the dosage form is not sinking at the bottom, or if it floats or sticks to the bowl uh, on the inner surface, so this will lead to the variation in the dissolution rate and the extent. Some dosage forms like capsule may be too light in weight, or some formulations which stick to the dosage stick to the dissolution bowl will require the sinker. And sinker has a particular weight. Whenever there is a light dosage form, that time sinker will give it additional weight. That's why the formulation will goes into the bottom, that will sink. So the sinker may be made by winding a few turns of a short loose piece of wire made of a suitably non-reactive material, generally stainless steel wire. So that wire is taken and winding is done for few turns around the dosage form to form a helix like a spring, and then the formulation is inserted into that spring like uh, winding of few turns of a wire, and it will be taken for the dissolution testing. So that is the sinker. Then what is the main role of the sinker when sinkers are required to be used? If the formulation shows floating inside the media in paddle apparatus, then sinkers are required to be used, because if floating is there, the floating will not be uniform for each of the unit, and it will give variation in the rate and extent of the dissolution. Like some of the capsule formulation float into the dissolution bowl. If the dosage form stick to the jar vessel inside, and if it is away from the bottom, then also the formulation will show variation and the dissolution will not be reproducible. Paddle apparatus, thereby each dosage form does not get the same hydrodynamics, and this results in the variation in the dissolution rates unit to unit. So tablet formulation also sticking to the vessel wall. If the tablet stick to the vessel wall, then there is no uniform landing of the tablet inside the vessel, and if this landing is not uniform, this will give variation in the dissolution results. Then if the dosage form is moving inside the dissolution vessel in the media, or it is spinning or dancing in the dissolution vessel in paddle apparatus, and thus results in the variation in the dissolution rates unit to unit, then higher RSD will be there. If minimum and maximum values are changing due to the formulation movement, spinning or dancing inside the dissolution vessel, there will be high relative standard deviation, and sometime also it will give dissolution failure. The floating, sticking and movement of the formulation is always variable and is not same for all the units, and thus this affects the rate of dissolution and introduces variability in the dissolution rate. All the units do not get the same hydrodynamics due to floating, sticking and movement of the dosage form. So if your formulation is showing movement like spinning, moving or dancing, that time every time when your batch is made and it is tested, every time the different results will be there, and it will be very difficult to decide the batch when you are going for the pilot bio or pivotal bio or for releasing the batch in the QC. So observation of the dosage form in dissolution vessel is very important, and it is very critical to decide for the use of sinkers. So whenever the formulation development is there, that time the dissolution should be observed critically so that the use of sinkers can be justified. Then the position of the dosage form in the dissolution vessel can be controlled by the proper sinker. The dissolution rate can be less variable and can be more reproducible by use of the proper sinker. Why this happens? Because sinkers take the formulation to the bottom of the vessel, and that will be uniform compared to the dissolution without sinkers. Now basket apparatus can also be used instead of the paddle apparatus, because you may think that if the paddle apparatus is used and if it is requiring the use of sinker, then simply I can go and use basket apparatus. So yes, basket apparatus can be used instead of paddle apparatus, but it is for some of the formulations only. If the formulation requires dissolution with strong mixing or hydrodynamics, then paddle apparatus is must. And if in the paddle apparatus the formulation is showing movement like spinning, dancing or sticking to the vessel, then the use of sinker is very necessary. Basket apparatus can also be used for some of the capsule formulations, but whenever the development is done for dissolution, that time apparatus selection is done, and if you select the paddle apparatus over basket apparatus, then use of the sinkers may be necessary if the formulation requires. Ideal sinkers characteristics are there. It should be inert and free from corrosion. So generally it is made for stainless steel, and it should be durable and easy to clean. Then sinker should give formulation a uniform landing inside the vessel. So if the sinkers are used and still you are getting the variation, that means you may have selected or might have selected a wrong sinker. So sinker evaluation should be done. Then sinker should not restrict the media hydrodynamics. If your tablet is landing here in the dissolution jar and after 5-10 minutes it is going to the bottom, then results will vary. So these sinkers are taken, capsule or tablet formulation is kept inside the sinker, and this will go directly at the bottom. Because these sinkers have some weight more than the formulation. That's why this will allow to sink the formulation at the bottom. Then selection criteria for the sinkers. What is the selection criteria? The sinkers have impact on the rate and extent of the dissolution. Also, it impacts the variability of the dissolution. So it becomes very important to select sinkers very critically and carefully. See, sinker should have minimal contact with the formulation, as this can affect the rate of dissolution. If your formulation is having much contact with the sinker, then variation will be there. The sinker should be heavy enough to sink the tablet capsule to the bottom of the vessel. If you have selected a very light sinker compared to the formulation, then it will give variation in the tablet landing. So the factors like dosage form, size, shape, density and weight are considered whenever sinkers are selected. Then sinker size and the dimensions. Sinker should have a minimal surface contact with the dosage form. Some formulations swell during the dissolution run. So this is required to be considered. If your formulation is showing swelling, then you should select ideally a little bit bigger size sinker. Then sinker material. It should not be non-reactive and corrosion free or corrosion resistant. Nowadays, stainless steel sinkers are there, coated sinkers are there, then plastic coated sinkers are there. These can be used. Then PTFE, polytetrafluoroethylene, that is Teflon coated, are also there. So these can be tried. Then sinker weight is another criteria. Sinker should be heavy enough to sink the dosage form. Then minimum weight sinkers are preferred. Whenever the formulation showing a good dissolution with 2 or 3 type of sinkers, then we should go with the sinker with minimum weight. Then sinker should have at least very less impact on the hydrodynamics. That means the movement of the media inside the dissolution jar. So sinker should have least hydrodynamic influence. Then one question was there, that can I use a sinker when USP monograph does not specify the same or does not specify the one. So if you have a monograph method, if you have a monograph for your product, and with that monograph method you are getting the variation, so can you use sinker or not? So the answer is, typically if a sinker is needed in a dissolution test procedure, we will mention the fact. There the use of sinker should be justified. Now where the use of sinker is not specifically mentioned in the procedure, it is safest to assume that the use of sinker would represent an alternative procedure. See General Notices section 6.30, alternative and harmonized method and procedures. As per the US Pharmacopoeia, non-reactive stainless steel wire helix is typically used to sink the dosage form that would otherwise float. So the simple answer to this question is yes, you can use the sinkers, and also if required you can make the correspondence with the regulatory authority. But generally sinkers can be used. These sinkers use can be and should be justified. Then types of sinkers. So various types of sinkers are there. Out of these, some are enlisted here. Longitudinal sinkers are there. So these longitudinal sinkers contact the dosage form on the long axis. Here example is shown. Then lateral sinkers. These wrap around or contact the dosage form in the middle. Then screen enclosures. These are the wire cages which hold the entire capsule or circular piece of the wire screen placed on top of the capsule. Internal weights consist of two steel ball bearings, one inserted into each end of the capsule. Then coated sinkers. If there is a reaction between the steel and the dosage form, that time coated sinkers are used. So another, based on the design, basket type sinkers. These can be used, but the outer coating of the tablet does not or should not clog the mesh. If this mesh is clogged, then it will restrict the media movement inside the dissolution bowl, and that's why it will affect the dissolution rate. So the bigger basket size sinker can be used. Then wire spirals. These should be as wide as practically possible to avoid clogging, which will affect the dissolution rate. So these are the wire spiral type of the sinkers. Then Japanese sinkers. So Japanese sinkers have specific dimension requirement, and these are specified into Japanese pharmacopoeia and have strict dimensions. So these dimensions are shown here with the diagram. This is the Japanese sinker. In this, the capsule or tablet is placed here, and then this lid is closed. Then tri-prong sinkers. In this tri-prong, the capsule or tablet is held, and these are available in stainless steel also, and as coated type of tri-prong sinkers also. These are also available in the Teflon type of sinkers. Then case sinkers. These are might be used for the small tablets or capsules, and in this the tablet or capsule is placed, this lid is closed, and then used further for the dissolution testing. Then U-type sinkers. This is the U-type sinker. Then breath film sinkers. These are breath film sinkers. Sodax type spiral sinkers. These are used for mainly the capsule formulations. Then problems associated with the sinkers. See, as the use of sinker give you advantage of less variability and avoid the problem of floating or spinning or dancing of the formulation. But some problems are also there. So sinkers can react with the dosage form, that is the problem. Then incorrect sinker may lead to improper dissolution results. Sinker clogging affect the flow of media and may affect the dissolution rate. Sinker should be validated before use, and method should mention the same. Alternative sinker devices may be required during the method development. However, the performance of the various sinkers is generally not equivalent, and the sinkers are not interchangeable unless validated. So if for one testing you are using prong sinker and then you are going to Japanese sinker, so these sinkers are not interchangeable and these should be validated properly. If the incorrect sinker is used or if the right sinker is not used, then you will not get the proper or predetermined type of dissolution results. So sinker evaluation is very necessary. Always try to use the different sinkers. Then some best practices are there. Perform dissolution with and without sinkers. So if you want to justify the use of sinker, that time take the formulation batch, the same batch to be tested on dissolution testing for the method with sinker and without sinker and compare the results. Then perform dissolution with different sinkers. If your formulation is permitting the use of different sinkers, then always try to check the impact of sinkers on the dissolution. Then finalize the sinker based on the practical results. whichever sinker is giving you the uniform landing, whichever sinker is showing very less variability, whichever sinker is showing the good hydrodynamics, these sinkers can be used. Then clearly mention the use of sinker and type of sinker in the method. Use the clean and correct weight sinkers every time. Then validate the method with the final sinker and mention it clearly. Then multiple strength of the same product may require different sinkers, and this is because the different strength have different weights, size and shapes. So same sinker should not be used for the same formulation and for the different strengths. So always have a different type of sinker evaluation for different strengths. Then coming to the summary, in summary we have seen the sinkers, their types, when sinkers are to be used, when sinkers are not to be used, and the best practices. So I hope this video will give you clear understanding on the sinkers for dissolution testing. And dissolution is the topic of great interest for the interview. Thanks for watching the video. Please do like, share and subscribe to Pharma Learning It channel and share this information with your friends and professionals. Thanks for watching the video.